cheated just like I cheated.
I looked. You're just like. No, I was looking at him and I'm like, okay, I'm looking for patterns. No, I was looking for patterns, and I'm like,
Oh yeah, I did that too.
well, I'm like, clearly it has to be R or S because of they both have pi and the cube doesn't. And I'm like,
Okay, you guys ready?
I did it too, but the 81's for real.
Are you ready?
I know how to do one, so I don't need to watch this.
Yeah,
Number-
so we're just not grading these, right?
Number 2, I need help.
I guess. Okay.
Number 4, I also need help. And number
You should have done a group
We
test.
should have done.
no, the group test would not have done anything.
No, I don't think anyone got anything right.
Okay, are you guys ready?
I got 1 right. I got 3 right.
Quiet, please. All right, number 1, you wanted to find the average value of sine, right? On the interval x from 0 to pi. Is that okay?
Yes.
This recording. Are you recording this?
Yeah.
Oh, it's live.
So you have sine, right? You want to go from 0 to pi, and you want the area under the curve. If you divide by that length, you'll get the average value of the function, right?
Yes.
Wait, which will?
I don't know.
We don't know.
So just integrate sine from 0 to pi to get your area, then divide by the length of the interval, which is pi. That's where you get the pi on the bottom.
Wait, why do you do this? Why do you do the half pi?
Because you divide.
I divide by, because if I have like a trapezoid,
I'm crying.
it's the base times the average height, right? So if I take the area divided by the base, I get the average height. So I'm going to take the area divided by the base and get the average height. And the area is the integral.
What is the trapezoid? Do with this. I mean, I put 1/pi down
Because the area is the base times the average height, right? So if I want the average value of a function, I just take the area and divide it by the base.
And the base is pi.
The base is pi, the length is pi.
Ew!
Because we're going from 0 to pi, that's how long it is. So
How much do I have to pay you to not take this test?
you've taken it. So the integral of sine is what? You guys know this.
What is the A?
Cosine.
Why do we put
Negative cosine, right?
I did put that in there, but then I just didn't know how to tie it in. So
I actually know that you do 1 over the base.
Yeah.
Oh, do I get an A
Why do you do
now?
one?
Wait, this
It's
is
on your
exactly what
sheet.
I'm looking
Are you just
Well, I
random?
didn't even look at this sheet just
Are you
now.
just?
I
are
know
you
that.
just
Do you
guessing
see where it says
or-
average value?
Yeah.
Well, I got 2 right.
I got more than 2.
How
I
many
got
did you get
3
wrong?
right. I got
You
3
didn't get the first one, that's for sure.
I think that's
All right, so
Wait,
that's
wait, there's someone
Where's
explaining
my
this to me.
paper?
Oh, we're
Why do you take
we're
the,
going over.
why
This is
is
40
it, why is it 1 over pi?
Because the formula said so. It said 1
Where's
over the
the
base.
Because I'm-
formula?
because
On
the-
your sheet.
the length of the interval is from 0 to pi, so the length is pi, right?
I was showing you where the
Wait,
formula
don't
is. Okay, you know?
Are you
That's
recording
Adrian
this?
doesn't want.
Yeah.
That's just to tell you, you just turn all this off.
Quiet, please. The length of the interval is pi, so that's how wide it is. You divide by the length of the interval. Dividing is the same as multiplying by the reciprocal, right?
Move on.
Just let him go.
All right, so plug in pi. Cosine at pi is -1. Cosine at then you subtract cosine at 0, which is 1. So you get, you get -2 here with the negative out front. It makes 2 over pi.
Something like that.
Wait, why is it -1 over pi in front?
Because the integral of sine is negative cosine.
I had that.
Okay?
Then why is it -1 minus 1?
Because cosine looks like this.
Yeah.
So at pi, it's -1. And then you subtract what it is at 0, which is 1. So you get
Yeah, I was
-1 minus
adding
1.
That's the issue.
You-
I almost got 0. I
Okay.
almost put 0.
You're right though.
I know.
Is that
I
okay?
almost put 0.
Yeah.
Because I was
For 2, you take
there's no way.
2, I don't know.
you
3,
take sine over that same interval from 0 to pi, and then you rotate it around the y-axis. So it makes that kind of bundt cake. right?
Yeah. This is actually.
So you just do a cylinder. You do cylinders. That's 2 pi r times h. That's the cylinder formula. So I'm going to integrate 2 pi r. The radius is the x value.
You read my answer for that? I feel like it.
Wait, no, wait. Where's the
Yeah, it's
answer?
in the- I'll look at it later. I'm just going to run through this. And then
Why are you?
the height was sine, right?
Maybe I'll just give up.
Yeah, I think you should.
Maybe
Put
I'm just,
sine squared x in it.
maybe I'm just done.
Yeah, I think you need the keys.
This is just sine.
Yeah, I put sine squared.
All right, so I'm just going to do integration by parts. There's a couple ways you could do that. You have the D and I table. Liate, right? So algebraic first. Derivative of that is 1, derivative of that is 0. Sine of x. It is sine of x, right? Yeah. Integral of sine is minus cosine. Integral of minus cosine is minus sine. So this integral would be 2 pi times this, so minus x cosine of x, and this 2 negatives. So
Will the retake be very similar to this?
Yep.
Very shallow.
It better be like the same.
so when I plug in pi, I get minus pi, and cosine at pi is minus 1.
So minus 1.
Positive pi then, right? And then sine at pi is 0. So then I got to subtract when I plug in 0, sine at 0, 0, x at 0, 0. So there's nothing there. So it's just 2 pi times pi, so it's 2 pi squared.
I take a picture of this. Oh wait, where's yours?
Somewhere.
Oh, Nate.
Is that okay?
I take a picture of it.
Yeah, post it on the classroom then if
I
you
mean, I
would.
probably don't understand it, but
Fair
That's
enough. I mean, fair enough. The next one.
3, you have the same thing, sine from 0 to pi. Now we're rotating around the x-axis, right?
I got the exact same.
So we have circular cross sections. That's good. So I want to use pi r squared for my integral, since I have disk method. So I'm going to go integral of pi sine squared x dx from 0 to pi. That's my integral. Is that okay? The setup?
do I have to understand the graph though?
Well, I drew the pictures for you on the test. So I'm going to use. I'm going to do the power reduction formula. So sine squared is the same as 1/2 times 1 minus cosine of twice the angle. So I have the integral of 1, which is just x, minus the integral of cosine. That should be sine, right?
Yep.
So sine of 2x,
Is that integral still 0 to pi?
but there should be a half here. What's that? Yeah, 0 to pi. Yeah.
Okay.
So there we go. Because if I took the derivative of sine, I'd get cosine 2x, then I have to do times 2, so that's why the half is there. So now I just got to plug in pi and 0. When I plug in 0, I get 0 for both terms, so that doesn't matter. But when I plug in pi, the second term goes to 0. So I only got to worry about this one. So that's pi squared over 2. Is that right? Is that what I had? Is that okay? Okay.
How's number 4 not 6?
Number 4 is U-substitution.
4 5. 4 all.
Next test.
Is
Oops.
this Will's text? Oh, it is. I was like, this is not my name.
So U would be x squared du would then therefore be 2x dx. So x dx is equal to 1/2 du. And I have x dx. So that's going to become 1/2 integral of cosine u du. Integral of cosine is sine, right? I'll see u is x squared, so that's it.
Really simple.
Hang on.
Just did not go into my head.
Yeah, I got that.
They will have that.
Good.
You know, I was really thinking about that.
It was like-
It was just on the tip of my.
Does it make sense now that I'm going over it?
Yeah.
Yeah.
Good.
Don't leave yet.
Okay.
Write it.
It's recorded. Or it should be.
That's all.
Yeah, but I don't
paper
trust
we
that,
did
Mr.
before.
Sotelo.
Well, I'm not going to make them too crazy. So sine's an easy integral. Cosine would be an easy integral.
I'm not gonna make it too crazy.
Not too crazy of integrals, right?
Yeah, right. Okay, I'm good.
Okay.
That question.
Okay, 5 is integration by parts. So I can't call u x half because then du would be 1/2 dx, and I have an x, so I can't use u substitution. So I got to do the Liate thing. I don't know which one you guys prefer. I'm doing the di table
I
here.
prefer that one.
Okay, again, the algebraic is x. Derivative of that is 1. Derivative of that is 0. E to the x over 2. Integral of that, you got to think of what the derivative of what gives you that. So actually 2 e to the x over 2.
Okay, I actually have that one.
And then 4 e to the x over 2. So my integral can transform into this. That is, I'll just circle it. This stuff. So that's x, or 2x e to the x over 2. And then I got this one, which is minus 4 e to the x over 2. And then the last bit has a 0, so that's where it terminates. If I evaluate this from 0 to 3, if I plug in 3, I get 6 e to the 3 over 2 minus 4 e to the 3 over 2. That's when I plug in 3. When I plug in 0, the first term becomes 0, and the second term becomes 4. So I'm going to subtract negative 4. So I get actually a plus 4. 6 times this minus 4 times this makes 2 times this. And on the answer, I just factored out a 2. Otherwise, that's fine. These are the same.
I had that all the way until we had to plug in points, 'cause I forgot.
Yeah, I don't know how to do limits with that.
Well, that's credit right there if you get that far. So
Sick.
Why did not get that?
That means I got half of a
I
point
got
right.
12 by 96, we got that right?
what's that?
12 by 96.
Yeah, that's the answer.
You know, 6, the answer has.
Okay, for 6 you had constraints. Basically,
Yeah, can we just like not do
No one.
Yeah, I definitely can't.
basically you had like a square cross section, and one of the sides was linear, one of the sides was kind of quadratic, and you just had to multiply the y and the z values together. So if I just took those two constraints, multiplied, you would get
6.
you get a function in terms of x. So just integrate from your 0 to 8 for x, and that's all you have to do. Just integrate that and plug in your limits. So it wasn't that bad actually.
So we all threw in the towel.
Real quick, I got 2 minutes. Okay, for the last one, you had the function x squared over 25 plus 9. When you wanted to revolve that around the x-axis, you have a disk method. So you're going to use pi r squared. So you have to square this, and you get x to the 4th over 625.
I have this one.
Yeah. So just integrate this times pi That was the one that matched because you have to square that function times pi. The one that matched when you revolve around the y-axis, you just have to use the inverse function. So solve for x. So you get y minus 9, the square root of that, times 20 times 5. And then you just have to do pi r squared. So square this times pi and integrate that for, now your new limits are in y. So that actually goes, when I plug in 0 to 10 here, I get 9. And when I plug in 10, 100 divided by 25 is 4, plus 9, it goes to 13. So you actually go from 9 to 13 times this squared, so 25 times y minus 9. And so that's the one that goes with.
Solve 3 out of 7.
No,
All right.
kind of.
Have a good day, you
It's
guys.
almost like we.
If you want to review, I'm here after school for the next 2 days. I'm before school every day, so.
Might have to come in tomorrow. Are you doing it Thursday, Will? No.